Good evening, YouTube, and welcome to my first CompTIA A Plus 220-1201 lecture video. Today we're going to look at Objective 2.1, which has you compare and contrast TCP and UDP and all the different programs and protocols that are used. Okay, so the objective states that students must be able to compare and contrast TCP and UDP ports, protocols, and purposes. All right, well, let's take a look at the list. What do we have here? Port 20 to 21 is for File Transfer Protocol, or FTP. Port 22 is Secure Shell, or SSH. Port 23 is Telnet. Port 25 is Simple Mail Transfer Protocol. Port 53 is Domain Name System. Port 67 and 68 is Dynamic Host Configuration Protocol. Port 80 is Hypertext Transfer Protocol. Port 110 is, Port 110 is Post Office Protocol 3. Port 143 is Internet Mail Access Protocol, or IMAP. Port 137 to 139 is Net BIOS, or Net Basic Input Output System. Port 389 is Lightweight Directory Access Protocol, or LDAP. Port 443 is Hypertext Transfer Protocol Secure, not to be confused with 80. HTTPS, didn't add that in there. Okay, port 445 is Server Message Block, or SMB. And port 3389 stands for Remote Desktop Protocol. Okay, so before we begin, we saw that list of different programs and protocols. What are some examples? Give me an example of TCP. Give me an example of UDP. What does that mean, TCP? What does that mean, UDP? Well, when I think of TCP, I think of a handshake. Basically, two computers agreeing to make a connection and staying connected until the task is done. So when you think of TCP, you're going to think that something's connected. It's more of a stream. It's reliable with air checking. It's a bit slower, but it is point to point. So system to system is connected. Okay, so basic TCP handshakes, or when computers connect, that's what happens. Okay, for this example, we'll look at UDP DORA. For DHCP, we have DORA, Discover, Offer, Request, and Accept. However, it doesn't stay connected forever. It's connectionless. It just connects for a second and then it's done. Instead of a stream, it uses a datagram. There's no air checking, so there's no way to know if it's successfully sent or not. If there's a problem, it just sends it again. It's fast. It's much faster, and it can multicast. It can go to multiple computers or multiple clients. It doesn't matter. It's not just for one. Okay, so an example that I could think for TCP handshake is when you go to a website. You browse the web, you go to the internet, and then the server sends you back a web page, and you stay connected on that web page until the next task is completed or moved on. However, for something like DORA, it's just a one-time thing. You get the IP configuration you need, and then you're done until that expires, until you need a new one. Okay, so let's take a look at the first ones we have here. Move this down. Okay, FTP. Move my face under FTP. FTP stands for File Transfer Protocol. Have you ever used FileZilla? Have you ever had a website that you needed to upload files to? You probably used FTP or something similar. So a client will send requests to a server and it gets a connection and it does a handshake and it stays connected. You can see the directories here and you can upload or download things as you need to the web server or the backend server or whatever it is. Maybe it's a SQL server, a database or something until it gets the files that it needs. Want to emphasize that port 20 is about the data and port 21 is about the control of the sessions. Okay. Moving on. Secure shell. Secure shell is pretty important. Use it at work all the time. A lot of different tools that I use on networks create this secure shell connection. So my data is encrypted and you can't see what I'm sending back and forth. So it uses a cryptographic protocol on any operating system, and you can get a command line to send commands back and forth from the client to the server. Okay, Telnet. Telnet does the same exact thing as Secure Shell does, but it's not encrypted and it's not secure. Take a look at this example here of Wireshark. If someone was sniffing the network and captured these packets, then they could essentially see all of the data going back and forth, and it's not encrypted. So any username or password or sensitive information can be easily seen on these packets. SMTP, Simple Mail Transfer Protocol. When I'm thinking of mail nowadays, I think of this protocol. So if you use Google Admin or use Office 365, these are most likely using SMTP or some secure way of sending SMTP. The main difference is that it synchronizes. So if you delete, for example, mail on your iPhone, it would delete it on your desktop, and it synchronizes back and forth. It's centralized. Domain name system. Um, this one is an example that's not TCP. It doesn't matter about your long-term connection. It just connects for a second, and when the job is done, it is done. So there's different kinds of name translations and name systems that can be used, but think of it like a phone book. When I say 8.8.8.8, a computer knows that's Google DNS or possibly google.com. But people don't know that. So when I say google.com, computers think 8.8.8.8 or back and forth. It's a way of translating IP addresses into a common name. Dynamic host configuration protocol. This one also uses UDP. It doesn't really care how reliable it is. It just wants to get the job done and do it fast. So when you ask for an IP address from your router or from some sort of enterprise device, it'll send you back what IP is available and assign it to you and give you a lease. You can see if you run an IP config, you'll see all kinds of information about DHCP and DNS as you are learning about networking. Okay. Hypertext Transfer Protocol. When you browse the web, there's different kinds of packets you can send to the web server, and it'll send you information back and display a web page. You can do different posts, and you can do different GET requests. However, it's not secure. So if I was observing the packets on the network, I could still see what you're sending. And if you sent any sensitive information, it's not a good option. Okay, we already talked about IMAP. Before we had IMAP, we had POP3 or Post Office Protocol 3. So instead of synchronizing, it would just send mail one way. And once you delete it, it's gone forever. Okay. Internet Mail Protocol or SMTP. Earlier, I was talking about the difference between IMAP and POP. Sorry, I was referring to SMTP, which is a mistake. That is a different mail protocol. But let's take a look at IMAP and POP. The main difference is IMAP synchronizes and POP does not. So most of the mail servers will be using IMAP. POP is old business. Nobody really does that anymore. SMTP can still use IMAP. Okay, NetBIOS, especially in a Windows environment. NetBIOS is pretty important. If you support Active Directory, any kind of name translation on a Windows server will use NetBIOS to talk to the different session layers and give you the resolution name that you need for a computer or a server or whatever device it is that you need to translate. Okay, Lightweight Directory Access Protocol stands for LDAP. That uses port 389. Think of LDAP as a way to find a person or an email address or a location or anything that you would use to identify a person in an organization. LDAP is great at that. So when you need to look at the address book, if you're going to scan to an email, that would be an LDAP request. Okay, Hypertext Transfer Protocol Secure. Earlier, we were talking about Hypertext Transfer Protocol, but that's not a very secure way to send information. We can see here that it uses port 443 when we're saying hello. Port 443 will let us know that it's secure, that's encrypted. It's not like HTTP with this encryption sign off. It will be locked and encrypted. And you know that the data that you're sending and receiving is scrambled and nobody else can read what you're sending. Okay, server message block uses TCP port 445. Server message block is when I think of a file share server. So anything that's being stored on a file share or on a network that you need to put on a network drive, perhaps, it's being on the network with server message block. I do see that this exam uses CIFS or Common Internet File System. I don't see that a whole lot. I see SMB a lot more, but for legacy systems, you might find something like that. And we have remote desktop protocol. Pretty popular. People still use remote desktop all the time. And if you have a Windows computer that's remoting into another Windows computer, you can create a session over this protocol. Okay, quiz time, compare and contrast. I want you to think of a secure port, think of an insecure port, and think of a connectionless port. How do these all compare? How do these all contrast? I'll give you a minute, stop the video, and think about it. And when you're ready, press continue. Okay, so I'm ready. Here are my answers. One thing that I can think of that's secure is HTTPS, or the information that I send over to a website is scrambled and it's secure. You can't read it. One insecure version, it would be HTTP. It's the exact opposite. It just connects to a web server, but sends all of my data and my traffic in the clear, so anyone can read it. And then a UDP port would be like DNS. DNS is really fast and quick. It doesn't care if it connects to you successfully or not. It just sends the packet and it's done. If you have a problem, you can just ask for another one. Thank you for watching and good luck on your exam.